We are starting today with Professor Dragos Cirneci, which I think you already know. He's a professor well known in Romania. Some short present. Well, some of us are his students already. So I personally was his student. So he's the reason why I'm studying neuroscience today. A few words about him. He is a published by product. So he's a product of the most prestigious university in Romania. He's a PhD there. He's an author. He wrote the first Romanian book of developmental cognitive neuroscience. He's dedicated to research. I encourage you to follow him on ResearchGate to see the latest research published by him. So, yeah, please welcome Dragos Cirneci. Professor, the floor is yours.
Good morning. Good morning, everybody. I would like, first of all, to thank Florin for inviting me, and also to congratulate Florin and his colleagues for organizing such a conference here in Romania. I believe it's a huge effort, but I wish them good luck, because they need it. And also, I would like to thank Florin for his very lovely words about me. Thank you, Florin. Why do I choose this topic? Because probably you can see on the screen, it's a general topic. It is not about my results on very later, for my experiments, but it is something strategic. In my opinion, because it is a conference addressed to the students, many to the students, I believe that our task as professors or researchers is in the first place to offer you a strategic guidance about what is neuroscience today, and especially what will be neuroscience in the future, because you will be part of this future. And for this, I'll begin to present you the main goal or task which was designated initially for the neuroscience. And this goal was to find and to understand the biological basis of mental processes and in the end of consciousness. And there are some examples here quoted from Eric Kandel, a Nobel laureate for the discovery, maybe you know him, the mechanism of memory encoding. And he mentioned here some of these mental categories like perception and action, memory, and others. And these familiar terms, you can find it in every handbook of neuroscience. Here is an example of one of the most well-known handbook of cognitive neurosciences, and you can hear it here in the content. Very familiar terms like perception, attention, memory, language, emotion, and language, attention, theory of mind. In every handbook of cognitive neuroscience, you can find all these terms. Actually, in the last 50 years of the 20th century and in the first part of the 21st century, this approach in terms of mind and behavior and the relationship between these mental faculties and behavior, or mental faculties as a biological basis of behavior, seems to be a well-established body of knowledge. And everybody agreed about this kind of taxonomy of mental faculties or mental processes. But I put a question here. How sure are we about the validity of this taxonomy? Can we find in the brain this organization of perception separate from attention, separate from emotion, from memory, from language, from theory of mind, creativity, and such other mental faculties. I will guide you through a historic approach. And this kind of mental faculties, as we can find today in a modern cognitive neuroscience handbook, we can find also in the first psychology book written by William James in the 19th century. And his chapters was consciousness, sensation, perception, attention, thinking, memory, imagination, emotion, and will. So very familiar mental faculties as we know them today. Going back in the 18th century, in the work of the British philosopher David Hume, also we can find the same mental faculties or processes or mental states he described, like impressions, feelings, imagination, will, thinking, vigilance, and others. And now I invite you to read this text. It's a little bit long, but I guess it's worth it, because at the first glance you can find it very familiar, and you can assume that I took it from a psychology or cognitive neuroscience in the handbook, because there appear the same familiar terms like thinking, senses, perception, intelligence, language, different effects. It is stated that we have mental faculties, affection, habitual dispositions, and there are a lot of examples about what kind of effects we have. But despite these modern terms of mental faculties, you can see here below the quote that it is part of the very, very old text. It is part of the sacred text of Hermes Trismegistus. It's a volume elaborated between the 2nd century BC and the 3rd century AD by the Alexandria School of Esoteric Philosophy. So it is very, very, very old. It is ancient, actually. And despite the fact it is ancient, you can see how modern seems to be their term, the term proposed by this esoteric philosophy school. But we can go also to the origin, or to find the origins of this long tradition of mental faculties. And probably some of you know that the first which proposed in written these faculties are Aristotle and his teacher Plato. Actually, Aristotle wrote in his text about these mental faculties, which he viewed as qualities or faculties of the soul, and mentioned for the first time the terms memories, imagination, thinking, emotions, and also he made a list of various emotions. From the history, it is known that probably Aristotle was influenced by Pythagoras, an even ancient author, famous also for his mathematical theories and other theories. So you know that all these theories, Aristotle's and Plato and Pythagoras theories about the soul and the soul qualities, like these mental faculties, but also other ideas about physics, chemistry, and biology, were adopted by the Christian Church and transmitted to the European world for several centuries. And all the Western civilization, like the European civilization and North American civilization, is based on this Greek philosophy, or Greek and Roman philosophy. So it is not, how to say, today is not mandatory to go to a school of philosophy or psychology to know this term. Our grandfathers, which are only graduates their high school, know these terms. They talk in terms of these mental faculties. They talk about instincts, intelligence, memory, perception, conscious and unconscious. So it is not something scientific. It is a well-known knowledge about the roots or the basis of human behavior. But also, maybe you are familiar with this approach of the battle between the cognitions or the rationality, thinking, and the emotions or feeling. And it is from tradition the task of the rationality to control the impulse or the emotion and the feelings. And this battle is what separates us from the animals, and only humans has this capacity of be rational, and being rational is the ability to control your emotions, which seems to be instinctive or animalic or something like this. But as you can see in the below part of this abstract from an article from 2017, written by Lisa Feldman-Barrett, the last 2 decades in neuroscience research have brought us to the brink of the paradigm shift in understanding the working of the brain. And as she says here, this work is setting the stage to revolutionize the study of mental categories. And the purpose of this presentation is to show you how it began this revolution in understanding the real functions of the brain and to move away from the mental categories. And for the start, I will present you some experiments in the early 2000s made by the people from the Department of Experimental Psychology, University of Cambridge. And I chose this example, and when they actually study perception, visual perception, and especially visual perception of the ambiguous stimulus. And they reached the conclusion that in the brain, it is an overlap between the parts of the brain traditionally designated to have a visual function, like the occipital lobe, and the parts of the brain which traditionally it's been seen to be the basis of the memory encoding, like hippocampus and other structures from the medial temporal lobe. And they propose, or they say that we should think outside of the boxes, of this module of the brain. It is not very useful, they say, to try to map psychological functions in the brain modules. And they propose that we can benefit by instead attempting to understand the functions of the brain regions or the brain modules in terms of the representations they contain and the computations they perform, and not to force this kind of matching between all psychological mental faculties and parts of the brain. Actually, they in the in the end of the article, they question this long tradition that the best way to understand the neural organization of the brain is to attempt to map psychological, or what they say, folk psychological constructs into different brain modules corresponding to different parts of the brain. Like they give us some examples from memory, perception, and emotion. In that period of time, not only this study contradicts the traditional view, but a lot of them. And in 2009, began a kind of established fact that the structure traditionally viewed as parts of the memory system, like the medial temporal lobe structures, are involved also in memory and perception. And actually, this part of the brain from the occipital lobe to the medial temporal lobe should be seen in a kind of hierarchy processing. And the processing began in the occipital lobe and moved to the medial temporal lobe. The result of this mixture between occipital and temporal lobe provides us what we call perception. And also this review signed by Mark Baxter from the Oxford University stated that these folk psychological views of cognition using mental categories or mental faculties may impede progress toward understanding how cognitive functions arise from the physiological activity of the brain. And to complicate more this, even more these things, I invite you to view this article from the Laboratory of Psychology of Harvard University, and are very well-known authors like Dennis Schechter and Donna Rose Edis. And this it's a classical experiment in neuroscience, and they put subjects in fMRI and ask them to remember some autobiographical events from their life, and another group to make some prospection of the future. They were asked to imagine themselves in the future, in a future event. And their conclusion was that is a considerable overlap in the neural processes involved in remembering the past, or episodic and autobiographical memory, and imagining the future. And you can see also here in the image below. It's a striking similarity. Also, people from the University of Graz, Austria, arrived at the same conclusion, and they study memory, episodic memory retrieval, but also imagination, and by using fMRI, and they observed that recall from episodic memory is considered as a central cognitive component for constructive processes such as imagination. And those may be equally crucial for the generation of novel ideas. And this conclusion actually strengthened the conclusion of the previous study, comparing autobiographical memory with imagining the future. Later, the people from the University College London, and they are also very famous, especially Eleanor McGuire, arrived at the same conclusion that traditionally memory, imagination, and prediction of the future seems to be distinct or different cognitive functions. But neuroimaging data, but also neuropsychology data and developmental data provide us evidence suggesting that an intimate link between these processes, or initially thought to be separate processes like memory, imagination, and future prediction. But this list was also added other cognitive functions like navigation. When we create a mental map in our brain to make a route from this point, from point A to point B, of course, without using a GPS, but also some social perspective like theory of mind, or understanding other people's thoughts, intentions, motivations. And it is quite striking because in a handbook of psychology or in a handbook of cognitive neuroscience, all these cognitive functions like episodic memory, mental navigation, theory of mind, perception, imagination. We can find this in separate chapters and not link with each other with different connections. And it is funny, I put here a quote from Ender Tulving. Maybe you know him because he is very famous. He's a famous Canadian psychologist from the University of Toronto. And he is the first who coined the term episodic memory, which later became, or part of them became autobiographical memory. He coined this term in 1972, but later, in a book in 2007, he arrived at the conclusion that the term memory is just an umbrella term, and it's covering all sorts of different things. And it is funny that he said that psychologists dreamed of coming up with a theory of memory have become as irrelevant as psychological theories about umbrellas. It is funny, but it is also sad because even such kind of prominent psychologists realize that this approach of separate mental categories borrowed from this old philosophical approach, it is not useful and take us to nowhere. It's a dead end. Not also cognitive functions is problematic, but also emotional functioning is problematic. And I put here a very famous author, Joseph Ledoux, from York University, and it is very well known for his work with amygdala back in the 80s and the first half of the 90s, which when he studied aversive conditioning in rats. And later his work was translated in the terms of mental faculties like fear and later anxiety. And he said in an interview that when he participated in different events, scientific events, he is introduced as someone who discovered how feelings of fear or anxiety come out of the amygdala. And he said that it is very wrong because he never said something like this. And he spent the last 2 decades actually emphasizing that amygdala is not a center of fear, or amygdala is not a center for anything actually, any kind of emotion. And fear, anxiety, and all the other emotions are not generated in the amygdala or other limbic and subcortical centers, but in neocortex, especially in the frontal lobe and some other related brain areas. As you can see here, it's a review from 2011, and they try to find in various imaging studies activations related with negative effects like anxiety. You can see it in the left part of the image. Also related with physical pain in the middle, and with cognitive control, especially attention and decision making, and performance in executive tasks like stroke tasks. And as you can see, these activations overlap in the same part of the dorsal medial frontal cortex, especially in the dorsal anterior cingulate cortex. And this overlapping contradicts, again, the philosophical approach of the battle between emotions or affect and cognition or rationality, or between rationality as a higher cognitive function and physical sensations like pain, because all of them actually share the same biological substrate in the frontal part of the brain. Another review from 2012, it's emblematic, I would say, because people from different prestigious universities like Harvard Medical School and Yale University, but also from University of California, Davis, University of Colorado Boulder and Northeastern University, with a review, a meta-analytic review about the imaging results obtained by different experimental studies, which try to find the localization in the brain of emotions, any kind of emotions. And their conclusion was shocking because their meta-analytic review did not find evidence for any kind of location of a particular emotion. So it is not correct to say that you can find fear in one part of the brain, and happiness in another part of the brain, and disgust in another part of the brain, and such on. But it is also striking that activation they found related with different emotions appear in different brain regions implicated in higher cognitive functions, like episodic experiences, like language, and executive attention, or executive functioning. Again, showing us this overlapping between emotions and rationality in the same part of the brain. And as you can see here in the picture above, most of these parts of the brain are part of the neocortex. The parts of the brain which traditionally are seen as being most sophisticated, the newer part of the brain. So emotions actually are something which seems to be very sophisticated in the brain and are not processed by some primitive subcortical centers of the brain. So to conclude, it became obvious in the last year that familiar categories of mental functions are misleading for us about how the brain works. And the idea that there's some kind of strong parallels between mental categories or philosophical and psychological mental categories and brain functioning is just wrong. Actually, there is no matching between mental categories from psychology and philosophy and the brain functioning. And all this mental content, which we traditionally call thoughts, feelings or emotions, perception, memories, imagination, decisions, actually are constructs or products of the brain functioning. They are not distinct entities in the brain. And actually, it's a kind of movie, as you can see here in the image. All these contents of the brain are a movie made by the brain about how he is representing the reality. They are not actually distinct mental entities or brain entities related directly with the mental faculties very well known from psychology and philosophy. So in the last year, many authors proposed to refocus neuroscience goal, moving away from these mental categories and try to find the real basis of the behavior, not based on mental faculties, but based on different brain mechanisms which can objectively be measured, because it was quite impossible to objectively measure any kind of this mental faculty, and being impossible to be objectively measured, they cannot be used to explain behavior, because any kind of this attempt to explain behavior took us to practice simpler explanation. And it's not a real explanation. So it is time to present you a new paradigm emerging in the last year, which tried convincingly to explain brain functions away from these mental categories. And it seems that the brain, the human brain, but all types of brain are not evolving to be rational, as Greek ancient philosophy thought in the past. But actually, this evolution's goal is to build a brain able to regulate allostasis. What is allostasis? Actually, allostasis is to anticipate, based on prior experience, what is happening or could be possible to be met in the future, and to regulate different biological resources and metabolic resources of the body to anticipate this challenging from the future, and different cognitive process like memory, attention, decision making, emotions, planning reflects allostatic processes. And the mechanism behind these allostatic processes are identified to be predictive coding and prediction error. Predictive coding explain such traditional processes like perception, action, decision making, emotion, interoception, and represents the attempt of the brain to combine information from memory and to generate scenarios, probabilistic scenarios about possible future. And every time this scenario is contradicted by the environment, a prediction error appears, and this prediction error has the goal to update the future predictive. Also, in connectonomy, different brain networks, or neuronal networks, were associated with allostatic processes and with predictive coding and the prediction error, especially the full mode network and Celia's network, but later other networks like ventral attention network, dorsal attention network, central executive network, sensory motor networks. All these networks were associated with allostatic processes, but especially the full mode network seems to act in a proactive way, trying to anticipate the future. And Celia's network seems to function in a reactive way. So probably the full mode network seems to be more responsible with predictive coding, especially long-term predictive coding, while Celia's network seems to be responsible with prediction error in updating the future predictive coding, and also in a strong relationship with interoception, with what we call traditionally emotions. The most prominent theory about emotions today is the so-called theory of constructed emotion, proposed by Lisa Feldman-Barrett, but also Joseph Friedman and others. And this theory is also strongly linked with allostasis, and posits that the primary purpose of the brain is to predictively regulate physiological resources in order to coordinate the body's motor activity and learning in short term, but also to meet the body's needs for growth, survival, and reproduction in the long term. And in this view, all these mental categories or processing like cognition, emotion, perception, and action, all of them are shaped by allostasis. And also decision making is not only cognitive, but it is embodied also and predictive, and is especially concerned with balancing energy needs, like metabolism. And we are up at the end of this presentation. I'd like to thank you, and if there are any questions.
May I ask a question?
Yes.
So first of all, thank you for the great talk. I would like to ask, you mentioned that there has been a move in neuroscience in recent years from regional localization of complex brain functions to this more integrated large-scale system analysis. And I wanted to ask, what are some methods that we need to use for this large-scale system analysis? Is there something new that needs to be developed, and are there some challenges associated with this new approach?
The main experimental approach is what is called resting-state functional connectivity, fMRI. And it is quite simple actually, but you need an fMRI and specific software. And the procedure is very simple. You can put a subject in an fMRI and a scanner and leave him for 11 minutes there. And he has to do nothing. Just stay calm, relax with eyes closed and try to not think about something particular. And during this scanning, the software is able to find the main brain networks in his brain, the connectivity inside the hubs of the networks, but also between networks. And using this approach, which is also doable with EEG, you can find several large-scale brain networks, by default, mode network, silence network, central executive network, ventral and dorsal attention networks, sensory motor networks, visual network, but also small-scale networks, a lot of them. It is not very clear the number of these small-scale networks. It depends by the software you use, but it is quite clear the number of the large-scale networks. And it is very important to understand that it's not easy to find the functions of the networks, because each network actually has various functions, and through the connection or hubs linking one network with other networks, that network acquired new functions temporarily. And all this picture is very different from what we know from the chapters of the handbook. And it's not possible to say that one network is responsible with visual perception, despite the fact that it is a visual network in the brain. But this visual network in the brain is also responsible with emotions, with empathy, with anticipating, imagination, memory, and such on. So it is not useful at all to try to map these classical mental categories in the functioning of the brain networks. This is why this approach is moving away from the mental categories and towards this homeostasis versus allostasis approach, and identifying mechanisms like predictive coding or prediction error and others to try to understand what actually a brain does to help us to survive and to regulate daily behavior.
I see. Thank you. Thank you very much.
You're welcome. If there are other questions. if no, I would like to thank you.
Thank you for coming.
Again, to congratulate you for organizing this conference and to wish you 2 very, how to say, fruitful days, today and tomorrow. And good luck with organizing maybe future conference here in Romania, and try to bring famous people we usually meet in the articles or books or on YouTube, and to store them and listen them live on a conference. And it is quite an honor, and I guess it is very inspiring for the students to be in contact with these people.
Professor, if you have a couple of minutes, there are some questions in the chat as well. So I would maybe read one out, or
Yes,
Florin,
yes.
do you want to read them from the Q&A?
You can go.
Okay. So Andrei Băsturescu is asking, could you please provide a list with the papers named in the presentation? And a second question, are you referring to the neurofeedback EEG approach?
Regarding the first question, I will pass the organizer a list of the papers presented in my presentation. It is very easy, and I will send them today or tomorrow, the list of the publications. Regarding the second question, neurobiofeedback is one of the approach actually quite different from the resting state functional fMRI. It is from the category of task-related fMRI, and give us an activation in the moment in front of a task. In this case, the activation in response to a feedback or to a comment. It's a complementary approach to the resting state functional connectivity. It's something different, but you can use this approach in combination with resting state functional connectivity. But one approach gives us the activation at the moment of task, and the other give you the alteration in time within the hubs of the network or between different networks.
Another question, what does it say about modularity? Philosophically speaking, modules like by Baron Cohen don't need to be physically separated in different regions, but only functionally. So what could these new findings change about the modularity of the mind?
This is actually a question I receive all the time from my students, and they don't understand the difference between a brain center and a brain network, for instance. Why they are so different? Because actually it's not possible to pinpoint a specific localized brain region and to associate it with a specific mental category. If you put a subject in fMRI and give the subject a task of attention, for instance, or visual perception, or empathy, or something like this, definitely you can find different activation in all parts of the brain. And you can be happy that you find the biological basis of these mental processes. But you become very sad when you search in the database of the brain and find that the same brain regions were associated with all kinds of other mental faculties with no relationship with empathy, attention, or as I said earlier. So actually, it is not possible to find any kind of overlapping between a mental category, any kind of mental category, and a part of the brain, because the same part of the brain is involved in almost any type of mental categories. So these results draw us to the conclusion that there is no mental category in the brain. There is no relationship between the activity of the brain and these chapters from the books of cognitive neuroscience or the psychology books.
All right, thank you very much.
Thank you.
Thank you, Professor, for coming.
Thank you again for inviting me.
And hoping that you are going to come to the next conference next year. Hopefully in presence. Good. Thank you.